Chapter 9, Database and SQL, and just due to time constraints and some issues, I decided to go ahead and get this out on an instructional in an instructional video format. So at least we go over over this information a little bit. Not that there's a whole lot to go over, but it's at least something I can do to make this work. Now, this whole section in Chapter 9 is talking about indexing. Now, indexes is a performance tuning method that allows faster retrieval of records. Okay, so again, the whole idea behind indexing is to performance tune, to make the system faster. Now, Oracle uses indexes to avoid the need for large table, full table scans and disk sorts. Now, what that means is that you, in any database, and let's take that customer record. Remember what that customer table looks like? Well, that customer table for every individual record, let's say, uses about 100 bytes. Okay, now a block is a segment of disk space, and each record fits into a block until it's full. Oftentimes there are many records within a single block. Oracle reads the entire block, whether it's looking for 10 records or 1. So indexing is a way to help Oracle not have to look at every single record in each single block in order to find get the results of the query. Now, with that said, that's why we talk about avoid the need for large table, full table scans. And again, a few records like we have in our customer database, not a big deal, doesn't make any difference. But if you have 10,000, 100,000, or a million records, it makes a huge difference. Indexes have 3 main uses. Quickly find specific rows by avoiding a full table scan. Just talked about that. To avoid table access altogether, and to avoid a sort, because you can sort that information initially through your index if you want to. Let's go. Now, this goes back to blocks. Really quickly, block is the smallest unit of disk that Oracle will read or write, so it has to read the whole thing, though. Now, these tables and this information are stored in blocks. Okay, the block size is configurable, usually 4K, 8, 16, or 32. So it just depends upon how you want to configure this particular drive and configure Oracle. Now, many rows will generally fit into a single block. So think about if you have one 4K block, and that each row of that, or each record of that customer table is 100K, you can fit 40 customers into a single block. So even if you're looking for just one customer, without indexing, Oracle will read the entire block. Now, the point is with that Oracle will actually read, once again, all those 40 records in that example, even though you're only looking for one particular row of information. So what this says is, so you never read just one row. That's exactly right. You read whatever's in each and every block. Okay, now, determining when to create an index. So you create an index, a couple of things really come to mind. First, when the table contains large number of records, when that's 10,000 plus, 100,000 million, that's where you use indexes. Now, a couple of other noted entries. Field contains wide range values, contains large number of null values. Now, queries frequently use field in search condition or join condition. So what you do is set up that field that queries frequently use, you set up as an index, like CUSER-ID. Now that's a username for accessing a computer system. So if you're searching on that CUSER-ID, sometimes, like if you go to certain sites, you can set up the user ID to be your email address. Well, in that user ID, then all of your record, your entire you on that particular system, everything about you, is indexed under CUSER-ID. Kind of similar to the primary key, but you can do this very same thing individually. Now, with a separate field. Now, a primary key is, as I understand, indexed in the same way this is indexing another field within your database. Now, probably as important as the first, the last, when most queries retrieve less than 2 to 4% of the table rows. So you're only looking for a couple of bits of information out of this long, huge set of blocks. A table will typically be a large set of blocks, maybe hundreds, maybe thousands of blocks that are actually 4K blocks. So if you're only looking for a little bit of information, you want to index it. Now, when you don't index, conversely, table does not contain large number of records. Let's see, most queries retrieve less or more than 2 to 4% of the tables. So you want to grab a whole bunch of stuff in the first place. So why should you index it? Because you're going to look through and you're going to be grabbing information out of that whole table or a lot of that table anyway. Now, this is the other part. You don't use an index when applications frequently insert or modify table data. So any time when that data is changed, you have to re-index the table. So if somebody just adds a name, adds a user, updates a phone number, that table has to be re-indexed if it's an indexed field. So that reduces the database's performance. Now, the next piece is this database table index. It's a distinct database table, even though it's something of an ad hoc table. Now, it's going to contain data values with corresponding columns to specify physical locations of records that contain data values. Now, and that physical location is row ID. Now, that's the internal location of record in the database. So this particular number right there, that's a hex number. That's the actual address, physical address on a drive where this particular field and record is stored. Because if you remember, you have CUser ID as Graham N, but you also have first name, last name, phone numbers, and all the other stuff that goes with it. Okay, so when you create the index, this is the regular syntax: create index, and then the index name, which can be anything, just like we've used in views and other things. On table name, so table, and in parentheses, field syntax. Okay, how do you get rid of the index? Just drop index user ID or whatever that name is. So the next slide here, we're going to go ahead and create an index on CUser ID. Now let me clarify here a little bit. Create index, this is just the name. CUser ID is just the name. On table, which is customer, and then field, CUser ID. Okay, so let's do that. So create index, the name, on the table, customer, parentheses, and then the field in that table. User ID semicolon. Now it should, okay, there we go. Index is created. That's perfect. Now the next piece of this is I'm going to actually go here and look at what the row ID is associated with this, well, the ad hoc table. That's what I'm looking at, it's the ad hoc table. So I'm going to select row ID and CUser ID from customer. Now CUser ID is the information that's been indexed, and the row ID is the related physical address where that particular information is. So if I go select row ID, comma, C underscore user ID from customer, I see the physical address and then the indexed information associated with that physical address. Okay, now what I can do, and I'll do this in just a second, what this is saying is I can select CUser ID, C last, C first. I can select all of this stuff from customer, where CUser ID is Graham N. All that's saying, you know enough to know what that's saying, is I'm going to go ahead and do this query and grab Graham N as my search criteria. However, because I'm doing this and I've indexed CUser ID, the CUser ID part will go out to the index, and the index will find the physical location of this information and then retrieve it more quickly. Will I see any different? I probably won't see any difference, but with such a small database, but if you had 10,000 records, you would. Now I'm going to grab that, paste that in there. I think my single quotes are okay. And there I go. It based upon the index, it looked and found where user ID was physically, then pulled up the rest of this information. So what's happening here is the CUSER-ID index will be used to search for the row ID of CUSER-ID Graham N. The query will then go directly to the specific record as identified by row ID right here, and then the query will display the selected information, just as with any other query. Now you can also do this with multiple queries, but that's where we'll go ahead and end. So that covers Chapter 9, Indexes, for our databases course. So thank you.